we use four techniques. The four integral techniques. Okay, so for number one, find the entire derivative of f of x. Okay, so integral of e to the x dx is equal to e to the x plus c. So find an antiderivative. An antiderivative, so e to the x. For part 2, we want to evaluate the following definite integral. So by the fundamental theorem of calculus, from 2 to 5, e to the x dx equal antiderivative 2 to 5. So e to the fifth minus e to the second. Okay. For number 2, the four integral techniques from the previous section, 6.2. Okay. Number 2. Okay, the area bounded by the x-axis and the graph of f of x. Note f of x is positive, so the graph is above x-axis. So this implies that the area is the definite integral, negative 2 to 9, 15x squared plus 4 dx. Okay, so by the fundamental theorem of calculus, this is 5, and one of antiderivative is 5x cubed plus 4x negative 2 to 9. So 5 times 9 cubed plus 4 times 9 minus 5 times minus 2 to the 2 minus 2 cubed plus 4 times minus 2. Okay, you can simplify it. You can use calculator to simplify it. For number 3, the net worth is f of t, and its derivative, which is the rate, is given by this function. Okay, so then the question is, how the net worth change during this period between 1989 and 2000. Okay, so the net worth changes. So the total change is given by the integral from 0 to since 1989 until 2000, so 11 years later. So from 0 to 11, 225350 minus 12t squared dt. So this is equal to, this is equal to 2250 t minus 4t cubed 0 to 11. So 2250 times 11 minus 4 times 11 cubed. So I think using your calculator, if this is positive, if this number is positive, if total change is positive, then increases. So answer is B. So I guess this is positive. Okay, so increases. And then the rate. What is the rate of the rate? So rate of rate is defined by the derivative of the rate. So f double prime of t is negative 24t, and t, this is and the range of t is between 0 and 11. So t is positive, not negative. So this is the derivative of the rate is negative, which means that decreasing rate. And if the company is worth 45,000 in 1989, what is worth in 2000? So the net worth of 2000 is f of 2000. Okay, so we want this. So so total change is calculated from the part 1. So this is equal to, one second. So net worth f of 2000 is equal to initial, okay, sorry, t is since 1989. So in 2000, 11 years after, we want this 11 years after. So this is f of 11 is initial worth plus total change, which is the integral. So f of 0 equal 45,000 plus the value of the integral. Okay. So you can simplify this number. Number 4. Now the questions are very technical. So use offline fundamental theorem calculus to evaluate the following definite integrals. Okay, for this one, by the second formula, antiderivative is 8 of x from 1 to 5, and 8 times 5 minus 8 times 1. So 40 minus 8 is 32. Number 5, again, we want to compute this definite integral using the 4 integral techniques from the previous section 6.2. So this one is equal to, let's express this as a standard form. So x to the negative 1/2. So the antiderivative is equal to, by the anti-power, increase the power by 1 divided by the power 1 to 4. So let's simplify this one. I'm sorry. If we simplify this one, the denominator is 1/2, so 2 times 1 over 1/2 is 2 times x to the 1/2, 1 to 4. So this is equal to 2 times 4 to the 1/2 minus 2 times 1 to the 1/2 is 1. So let's simplify it. This is 2. Okay. For the next question, use the fundamental theorem calculus. Again, the same question. So let's express this as a standard form. So 4 times x to the 1/2. For this one, by the property of integral, this is equal to 4 times integral from 4 to 9 x to the 1/2 dx. So this is equal to 4 times the antiderivative is x to the 1/2 power increased by 1 divided by the power 4 to 9. Okay, so this is equal to 4 times, let's simplify this expression. So denominator is 3 over 2. So upside down 2 over 3 times x 3 over 2 4 to 9. So equal to 4 times 2 turns 9 3 over 2 minus 3 over 2 4 times 4 to the 3 over 2. So 4 times, so 3 over 2 is the common factor. So 8 over 3 9 3 over 2 minus 4 3 over 2. So 3 over 8. So what is 9 to the 3 over 2? 9 is 3 squared, so it's 3 cubed minus 2 cubed similarly. So 8 over 3 times 27 minus 8. This is equal to 8 over 3 times 19. Okay, so 3 152. So you can skip the intermediate steps, okay, if you want. Number 5. Okay, again, applying the fundamental theorem of calculus. So this is equal to the antiderivative of this one is natural log of absolute value of x 2 to 3. So this is equal to 3. Common factor ln 3 minus ln 2. You can simplify as ln 3 over 2. Or you can just leave it. It's okay. Number 8. So now also you want area. So note that fx is non-negative, so above the x-axis. So the area is just equal to integral from 2 to 7 12x squared ds. So this is equal to the antiderivative is 4x cubed 2 to 7. 4 times 7 cubed minus 2 cubed. Okay. Okay. So number 9. Again, for this question, you can find the average value. The average value. So average value is given between 0 and 1. So the average value is given by the formula 1 over the length of the interval integral from 0 to 1 e to the 0.4x dx. So this is equal to, the coefficient is just 1. And antiderivative of this one is by the formula 0.4 e to the 0.4x 0 to 1. So this is equal to 1 over 0.4 times e to the 0.4 minus 1. Okay, so you can simplify it. Use your calculator to simplify it. Number, draw the graph of fx on your calculator. Okay, so this is the exponential function. So if I draw the graph at 0, it passes through 1, and the coefficient of exponent is 0.4, which is positive, so increasing, exponential growth. So this is graph of f of x. Exact x value of fx is the average value, so 0 and 1. Okay, how do you compute? And the average value of the on the graph. Average value is like, so it's, if you use calculator, average value is 1.22 something. So 2 is here, so about this. This is the average value, okay? Exact x value for its fx is the average value. So you want to find this value, okay? So f of x is equal to the average value computed. So this is equal to f of x is equal to 0 e to the 0.4x. So take the log, then 0.4x equal natural log of 1 over 0.4 e to 0.4 minus 1. Okay, so x equal ln of this value divided by 0.4. Then simplify. Okay. The last one, number 10. Area bounded by x-axis and the graph. Okay, so in this case, I'm going to sketch the graph. Okay. Okay, bounded by the x-axis. So let's find the intersection points on the x-axis. So set 4x cubed minus 4x is equal to 0. Then solve for x squared minus 4 equals 0. Then for x plus 2, x minus 2 equals 0. So it intersects at 0, negative 2, and 2. So if x is bigger than 2, the graph is positive. Then negative and positive, this graph looks like this. Y equal s. 4x cubed minus 4x. As you can see, x is bigger than 2, y is positive, x is less than negative 2 is negative. Y value is negative. So we want to find the area, these areas. Okay, so if the graph is below the x-axis, we need to be careful. Let's first the area. Let's say this is A, this is B. Then the area of A is given by the definite integral minus 2 to 0 for example 4x cubed minus 4x. The area of B is minus 1, 0 to 2, 4x cubed minus 4x dx, because the definite integral is the negative area, negative B. So this is equal to x to the fourth minus 2x squared, okay, from negative 2 to 0. Then this is equal to 0 minus, plug in negative 2, 16 minus 16 minus 16 minus 0 minus 16 minus 8. Okay, 16 minus 8. This is 8. 1 second. It must be positive. Oh, there is a mistake here. Algebraic mistake. Okay, sorry about that. So this is 1, 4x cubed minus 4x, and x plus 1, x minus 1. So this is minus 1 and 1. The intersecting point negative 1, 0, 1. So from negative 1 to 0, 0 to 1. Sorry about that. So this is minus 1 to 0. From minus 1 to 0. So 0 minus, plug in minus 1, 1, minus 2, minus minus 1. So this is 1. And this is equal to x to the fourth minus 2x squared, 0 to 1, and minus sign here. So this is minus, plug in 1 equal minus 1 minus 0. So this is 1. So the area is equal to 2. Okay.